Hello, I'm Subtract, and this is my video coverage for the bonus project number 1, 4-bit addition and subtraction. First, looking at the logic flow diagram, you can see we have 6 logic gates per bit. Each of these sections give you a S out and a C out. These are in order: bit LED 0, LED 1, LED 2, LED 3, and C out, LED 5. Looking at the first section, we have 6 logic gates. The first one, at each segment, each part, is only to invert the bits for B and is not a part of the full adder. These full adders have 5 logic gates per, 2 exclusivors, 2 ANDs, and 1 OR. In these cases, you want to finish the exclusivors first, and then ANDs, and finish with the OR. Starting with the first example, well, I'll just cover this. You take your B0, take the sub value, invert it if needed, get the B prime, B0 prime. These, with the B0 prime and A, will give you X0. X0 is just A plus B. And since you have a sub value, which is the carry out from the previous section, there's no previous section, so sub is 1. You'll get S, S0. S0 is just A plus B plus C. After you're done with the exclusivors, you'll go to your AND. A0 and B0 prime will give you C01, and A plus B, X0, and sub will give you the C02. These are just the two halves of the carryout. Only one of them will be a 1. So you just put them into the OR to find out if either one is positive. If it is, you will have a positive carryout, which will then go into your second section. For the second bit, same again for the third bit, same again for the last bit. At the last section, your C out will be your LED 5. I have made a Fallstadt animation for it. Here's a link for it. tinyurl.com /468 P2AH8. Here's a link for it. It works out. It works properly. 1001 is 1 and 1 is 2, right? It works out, and we will use it to verify our example case. Example case, step-by-step analysis. 1001, I chose number and -1. Looking at the analysis, you can see that we start with the B. You take your B0, which is 1, invert it at the exclusivor, you'll get 0. You'll take your 0 B out, B0 prime, and your A0, 1 or exclusivor 0, it will give you X0, which is positive. You will take the positive value from the exclusivor 2 to your next one, which is the last one, with the sub value as shown in the diagram, and you will get your first ever S0. You'll just take it out, so just keep it in mind. It will be your first bit value. After you're done with the S, you'll go to your AND. A0 and B0 prime, 1 and 0 is 0. So your C01 will be 0. The next section is X0, X0, which is 1, A plus B. Since it is a 1 and the sub value is a 1, you'll get C02, which is a 1. Since either one is fine in the OR case, your C out will be 1. Going to your second step, the difference is, as you can see here, the sub value went into exclusivor 3 and AND 2. But since we have a C0 already, you'll just use it instead of the sub value. You just repeat this, as many times as you have. In this case, 4 times. S0, 0, C01. S10, C11. Third step, S20, C21. S31, C31, which at the end gives you C0, this section. 1001 minus 1 is 1000, and if we ignore the first LED, we have the correct amount. So to verify it in Fallstadt, let's go like this. 1001 1 minus, we get the same result. 1001 minus 1, we get the 1000 value. So then again, the link is here. If you want to use it, check it out. And if the wiring is too complex, you can also just treat each line here as a single full adder, right? Since top left of the circuit, here, top left can be X0, top right can be S1, C02, C01, C02, and C out. You can just treat a single line as a full adder instead of having to make them zigzag. And that's the ending of my report video coverage. Thank you.